Hello, everyone. This is Ira Winder, and I'm speaking on behalf of the University of Tokyo and MIT to present our work on user interface design for multi-objective decision-making. A little bit of background on our lab. We develop multi-objective decision-making tools in the form of software to deploy in environments, workshops with decision makers working on engineering problems. The typical form of our work is computer simulation that is integrated with user interface environments that decision makers can use, especially if they don't otherwise have technical background in computer modeling or simulation. In the form of an object process methodology, we can think of our work as a transdisciplinary model making process where the central pursuit is the creation of a solution. And of course, the most important stakeholder related to that solution is the user. So for instance, if we're designing an energy grid and we are trying to create a good solution for an energy grid, the principal people we're concerned about helping are the users of that power grid, the residents, the businesses, etc. Another important part of transdisciplinary model making is the definition of objectives. And sometimes those objectives are implicit, but sometimes those objectives are informed by the model making process itself. And also important is the idea of a decision maker. The decision maker could be an executive, it could be representatives of the users, it could be a single person or a collective of people or institutions. But the most important thing is there is, to some extent, beyond the users, a subset of people who are responsible for ultimately taking in a bunch of information and making a final commitment to a solution based on the best information that they can create. The emergence of decision support systems has become a very integral part of linking the wealth of data and information and modeling techniques to a decision-making process by non-experts. So that lower box in this diagram is that decision support system concept. And we've also included on the right the idea of model makers as a very broad umbrella term that contains perhaps systems experts, the engineers, also the computational modelers and developers, but all of that domain expertise that's really hard to be proficient in without a lot of specialization. And those people also, of course, contribute to transdisciplinary engineering. So in our work, we've adopted this model roughly where the model makers and the decision makers are separate stakeholders, and we've often assumed the role of model makers. As model makers, we've developed a number of bespoke decision support systems where the configuration, the architecture of these decision support systems is such that the computer model and simulation of the system that we are trying to make a decision within is separate from the user interface or the front end of the software that is used to control and configure the computer model of the system in question. So after many times of doing this work, we noticed that the bespoke user interface that we were creating every time for any given systems engineering problem or multi-objective decision-making problem started to look the same. We started seeing patterns and reoccurrence of features. So this work largely proposes, as you see in green now, to create a design for a generic user interface that is reusable and allows us to focus our energy and resources on computer model making rather than rebuilding a user interface every time we go through this process. The way we identify and design a generic user interface is by essentially looking at a bunch of case studies and seeing what we and others have built over and over again. Because if they are built over and over again, they are likely generalizable and standardizable features that could be useful in future work. We use 6 case studies that you see on screen, all from different domains, but the same architecture in the object process methodology you saw in the previous slide. Patterns that we can then glean by putting them side by side are then framed as a set of user stories that are compatible with agile software development. Now, when I say user stories, this is a term that software developers often use to set a development goal or an objective so that when they build a piece of software, They are always thinking about the end user of their work and how it serves them. The reason we choose to frame our findings this way is so that we can make it possible to take our research and implement it as a practical piece of software as quickly as possible. One, because we plan to do that, but also we hope others might want to try to do that as well. Here's an example of one of our case studies, just to show you the rough layout of a case study and how we start to pull out some user stories based on that user interface configuration. This is a snapshot of a maritime shipping decision support system. The left panel shows a set of decisions that a user can make, and upon configuring them, they can create a scenario by hitting the simulate button. A scenario is an individual configuration of a shipping fleet that they can then see the performance of, the simulated performance of, in terms of all of the variables you see listed on the right-hand side of the screen. Another important part of these DSS is not just to make decisions, but view the performance according to multiple objectives, and not only see them all the objectives, but filter which objectives are important for any given moment of decision making. And then finally, we very often incorporate the ability of the decision maker to see not just the performance of one scenario, but multiple scenarios in series so that they can actually compare one solution to another. After putting together these case studies and trying to find the patterns, we identified 20 unique user stories for a generalized user interface. The user stories are framed from the perspective of either a model maker or a decision maker. So for example, a decision maker should be able to blank, or a model maker should be able to easily blank. And the reason we do this is because these are both users of the system, but from different standpoints. The model maker has to create software that can be integrated into the generic user interface, whereas the decision maker sits at a computer and ultimately uses the interface to make decisions. The user stories are further sorted into 10 categories. We think these 10 categories are going to be useful for prioritizing work and development, and also just understanding the overall goals of what we think a piece of generic interface software should accomplish in the context of multi-objective decision making. Finally, in our paper, you'll note that each category is annotated with the specific case studies that informed its selection. So we hope that'll be helpful to understand why and how we chose those examples and those features. So in conclusion, we have assembled these 20 user stories and laid them out in the paper. And we believe that they are ready to be integrated into an agile software development pipeline. And while we invite anyone to start developing this right away, our research community between MIT and UTokyo will begin our own development of an open source project that meets the guidelines of these user stories, because ultimately we think a piece of software like this will be immediately useful. It will save a lot of time for our researchers and make it easier to develop and deploy decision support systems in transdisciplinary engineering. Of course, we think a big part of future work will not just be the implementation of a practical piece of software, but the experimental methodology for testing the efficacy of the software. So not only do we need to build something, we need to prove to ourselves and others that it works the way we think it works, or the way we want it to work. Does it actually help the decision-making process? Does it hurt it in a way we didn't expect? These are the things we want to discover. So thank you very much for listening. We welcome your feedback and comments, and perhaps even participation. So reach out to us. Again, this is Ira Winder representing UTokyo and MIT. Thank you for your time.